now let's meet a scientist who's looking at how different conditions affect ice and snow.
Flakes, flurries, or powder. Whatever form it takes, snow is great fun while it lasts. We get up to all kinds of winter activities on the snow before it melts away. But what's the science behind snow melt? It's actually pretty complicated, but we can measure it in a few inventive ways. Snow melts because energy goes into it. We call this the energy flux. But this energy can come from lots of places, like heat from evaporation, heat from the warmer ground, radiation energy from the sun, and even warmth from water like rain. All these different sources make heat flux tricky to track. Luckily, we have plenty of sensors to help us figure it out. These include wind and gas sensors, temperature and humidity sensors, and rain and snow depth gauges. We even built special sensors called thermocouple ladders, which tell us the temperature inside snowbanks. These are all built into structures we call energy flux towers, which sit outside in the snow and gather lots of data, which can all be fed back to our lab in real time. There's not much snow in a lab, so we headed down to the Australian Alps to deploy our energy flux towers. We install our sensors and towers before the snow arrives, on the ground and on the bases of trees that will soon be covered deep in snow. This site is amongst the trees because we want to learn how the trees affect the snow building up and melting away and compare this with open areas. Then, winter sets in and the snow begins to fall and build up. This is called accumulation, and we're also very interested in snow ablation. This is the term for any process that removes snow from the area, like melting or evaporation. For example, an anemometer measures three-dimensional wind speed to tell us how much heat is being pulled out of the snow, and a handheld device measures how much radiation is being blocked by the tree canopy. Thanks to solar panels and battery packs, our energy flux towers are constantly recording data too. We discovered that the Snowpack is a bit like an ice sandwich, warmer at the top and bottom and colder in the middle. This is thanks to the warmer air temperature and heat from the ground. Our thermocouple ladders are measuring this thermal energy every 10 centimeters through the Snowpack to show us where the heat is stored. We even have sensors measuring the warmth of the tree trunks. So with all these sensors, by combining the data, we can start to get an idea of the snow melt. We can learn how much water is stored within the snowpack, in forested areas and open areas. We know that out in the open is where the highest energy flux happens because there's no tree cover to block solar radiation. And we can predict which types of weather will cause the highest snowmelt, which helps to manage dam systems that make energy and store water. Then we can power our sensors down until next winter and the next great snowfall.